Okay, so we're going to go over quadratic formula, which is this equation here. And we're going to talk about factoring along with the quadratic formula. The whole reason you would use essentially factoring is to go from the standard form of a quadratic to the factored form. And you can use factoring, or you could technically use the quadratic formula to do the exact same thing. Okay. Always we would start in standard form and essentially move to factored form. And the quadratic formula will tell you your x-intercepts. You'll take that information and fill it in to recreate it in factored form equation. So let's say we have this equation here. There's kind of two ways we can go about this. One of them is factoring and one is quadratic formula. I'll go through quadratic formulas first, and then I'll just do a style of factoring, and just to show you the relationship between the two. Okay. So using the quadratic formula, it's essentially going to solve for our x values. Now, in standard form, we have two x's, one of them squared. So there's a whole isolation process that somebody's done to create the quadratic formula. So the quadratic formula is equal to x. Then we take our b value, so we should say what our b value is. In this case, it's 15. Our a value is 18, and our c value is -3. We take our b value and we make it negative. So if this was already -15, it'd be negative 15. But because it's positive, it becomes just -15. Does that make sense?
Yeah.
Okay. From there, we have the root. Okay. So underneath that, we take our b value and we square it. So that becomes 15 squared. And then we have subtracted by 4 times our a value, which is 18, times our c value, which is -3. Okay. And all of everything there will be divided by 2 times our a value, which is 18. Okay, so let's kind of go through this. -15 plus or minus. We'll take our calculator out here. Great. 15 squared is 225. So 225. And now, here we have, think of it like -4 times -3. So that's going to be a positive, and it's going to be positive 12. So it's really positive 12 times 18. When you're multiplying, it doesn't matter what order you do things in. So I just did that so I could put kind of less information here. So I know it's actually just positive 12 times 18. So plus 216, that's what happens underneath this. Does that make sense?
Yeah.
Make sense? Yeah, okay. And then underneath we have 2 times 18, which is going to be just our 36. Okay. Then we'll have the root of this. So x is equal to -15 plus or minus. We'll have to add those together. Let's see if we can do that. It's going to be 241, I believe. No, 431. 41. Oh my gosh, hold on. 144. There we go. 441. Great. Divided by 36. Okay. Now, we'll normally work in decimals, right? There's a way where you can reduce these. They teach it in a different math class, but we'll draw a relation to it maybe after. Let's find the root of this to start. So root of 441. Is that the right number? I hope so. Oh, great. It's 21. Great. So that worked out nice. X is equal to -15 plus or minus 21 all over 36. So this is essentially where the equation splits. And remember, we're trying to change it into factored form. And a lot of times with quadratics, you have two x-intercepts. So that's why it splits. You have two options. You have x is equal to -15 plus 21 over 36. And you have x is equal to -15 minus 21 over 36. So before I change all this to decimals, I'm going to try to reduce it to a fraction because I do want to kind of draw a relationship to it. -15, 21 is going to give us 6. Okay, which is 6 over 36, which is actually 1 over 6, and which would be actually equivalent roughly to 0.16 repeated, I think, something like that. In our other one, that is 36. So it's -36 over positive 36, which is -1. Okay, so we've now found our two x-intercepts. One of them is at this value, or the fraction, and the other one's at -1. So if you remember our factored form, f at x is equal to, because we did it through the quadratic formula, our a value will be the a value we had at the beginning. So in this case, the number 18. We'll fill in there. And we'll just kind of slide it down so you can see from our original. Our original is our a value goes here, and we have our x minus r and x minus s. Okay, so our a value is the 18, and our r and our s are whatever our values were here. So we had 1/2 as one of them, so x minus 1/2, or sorry, not half, 1/16, and our other one would be x minus -1, which simplifies into 18x minus 1/6, and x, these two become +1. Okay? So this time I'm going to actually factor this. And the first thing we can do is common factor. There's a common factor of 3 in everything. Okay? So I'm going to quickly pull that out. So already our factor form is kind of looking different because we have an a value, right? This will give us 6x squared plus 5x minus 1. I tend to factor by finding the factors of the first term and the last term. The last term is 1 and 1, and we have 1, 6, 2, and 3. Okay, and I can quickly tell that it's probably, I need two numbers that add up to 5. So I need my products. 2 add up to 5, and then they still satisfy this part here. So we have our 2 times 1 and 3. That looks good, but the problem is one of these needs to be negative, because in order to get -1, I have to multiply -1 times +1. And if any of these are negative, we're not actually going to equal 5. So that actually didn't work out. So even though my instinct said 2 and 3, it's probably going to have to be 1 and 6. So let's take a look. 1 times 1 and 6 times 1, that gives us 6 and 1. And if the 6 is positive and the 1's negative, that gives me +5. Which means this one would have to be negative. Okay? So with that being said, I can now go right into my factors form. I have my 3. This will be my first term, so I have 1x, and you always put the opposites in the same bracket. So because I multiplied 1 times -1, I put the +1 in the same bracket. Okay? And in this bracket, we have 6x, and the opposite value is -1. So let's think back to our other form. Well, my other factored form said, our other version reads our 18, and we had x minus 1/6, and x plus 1. So these two look very different, but they're actually the same equation. And if you were to do FOIL, and I'll do it really quickly here, both at a time, x times 6x is 6x squared, x times -1 is -x, 1 times 6x is 6x, 1 times -1 is -1. We collect our like terms, so we have 3 6x squared plus 5x minus 1. Okay, and then we distribute the 3 to each of the numbers. We have 18x squared plus 15x minus 3, so that's exactly where we started. In this version, we have our 18, x times x is x squared, x times 1 is x, -1/6x, and -1/6. Collect our like terms, 18 gives you x squared. And this would become +5/6x, and that becomes -1/6, okay? And then we distribute 18. 18 times x squared is 18 squared. Think of this like this. 18 divided by 6 is 3, and 3 times 5 is 15, so plus 15x. And same idea again, 18 divided by 6 is 3, 3 times -1 is -3, and lo and behold, you have the exact same standard form of equation. Okay, so that just goes to show you that whether you're using quadratic formula or factoring, you can essentially build the exact same factor form of an equation.